Okay, we are recording. So we did a first exercise last time with 4 PC. Now we are going to do a second one. So we already talked about it last time also, about this practice. So let me review it with you. In this network, in this internetwork, we have 3 different networks. So each interface of a router will be a different network. So we have a first network here. This network is 10.2.5.128/25. As you can see, this interface of the router, which is Ethernet 2, belong to this network, PC5 and PC6. And of course, the transparent bridge also, or transparent switch, also belong to this network. So we are going to do this, a practice, to see how we will have to configure all those devices to have this internet working. So I'm going to start GNS3. Last time we called the project how do we call the project last time? Lab 01? Okay, so let's create a lab 02. Thank you. Okay, so let me try to have both so we can work a little better. Okay, so I need 3 switch. So I will go here and take an Ethernet switch. Let me call it S1, for example, or SW1. I'm going to duplicate it. We got SW2. I'm going to duplicate it. We got SW3. We have only one router. It will be a PC with 3 interfaces. And we have 1, 2, 3, 4, 5, 6 PC. So I go to the end devices, and I'm going to use the Debian 7 here. Let me call it PC1. And duplicate it, no? And we need PC1, PC2, PC3, PC4, PC5, and PC6. So let me duplicate it. We have PC2, duplicate, we have PC3, duplicate, PC4, duplicate, PC5, and I'm going to duplicate it again, and we have PC6. Now we need the router. The router will be also a Debian box, but with 3 interfaces. So let me duplicate PC6 and change PC6. So I'm going to call it router, as you can see, and this will be our router. So since the icon that I'm using represents a PC and not a router, I can change the icon. If you want to change the icon in this software, you right click here and you have here change symbol. So in Classic, I'm going to search for a symbol of router. This is just a representation, no? It will not affect the behavior of the device. So it's still a Debian box. And if you look, I have my mouse over the router, and it only have one Ethernet interface. It is called ETH0. I need ETH1 and ETH2. So look at what I'm going to do. I'm going to right click, and here in the context menu, there is a configuration option. I choose it, and in network, you can say how many network interface cards you want. I want it to have 3 network interface cards. So I put 3 and click OK. When I put my mouse over the router, look at this time. It says that you have Ethernet 0, Ethernet 1, and Ethernet 2. It's like if it were a real PC. I open it, I bought some Ethernet NIC, and I put them into the free slot that are available, no? So now we have everything to do our graphics. So I'm going to do it. We have the router here. We have switch 3 here. We have switch 1 here. We have switch 2 here. PC1 and PC2 will be connected to switch 1. PC3 and PC4 will be connected to switch 2. And PC5 and PC6 will be connected to switch 3. So PC5 here, PC6 here. Okay, so let me do the physical part. I'm going to take the tools, which is the cable, and I'm going to start to do some cabling. So look, when I went to PC5, there were only one interface available. Here it's a switch, it has 8 interfaces. You can connect wherever you want. It's not important in a switch where you connect. So here, any interface, I go to PC6. Here, any interface in the switch, I go to PC1. Here from PC2, I go to any interface of the switch. Here from PC3, I go to any interface of the switch. Here from PC4, I go to any interface of the switch. Doesn't matter. So here we want, on the router, we want ETH0 to be connected to switch 3. So when I'm going to click on the router, it will show me 3 interfaces because I added 2 additional interfaces. So I want to go from Ethernet 0 to any interface of the switch. So I did this connection. Then you have a connection between Ethernet 0 and switch 1. So if I click, 3 are Ethernet 0 and Ethernet 1. I'm going to go from Ethernet 0 to any port of the switch. And from any port of the switch, I'm going to go to Ethernet 1. Okay, so physically, I have done what I need to do. Okay, my interconnection is done at the physical level. So I'm going to start some devices. For example, I'm going to start PC1. So I right click on PC1, click on start, and it start booting. No, I double click the icon. And as you can see, we have the Debian Linux that is booting. It will take a few seconds and it will be ready to be configured. It is there. So let me also start, for example, PC2, start PC3, start PC4. Of course, configuring all these devices will be time consuming. You know, we are not going to configure all of them, but some of them. Okay, here I am in PC1. So I'm going to do something that I should not do. I'm going to enter like root directory, and the password is 2. Okay, I want this device to be called PC1. And I want the configuration to be non-persistent. What can I do? Non-persistent is if I boot PC1, I will lose all the configuration that I'm going to do because these configurations are not stored in a file. So I want to change the name of PC1. In this moment, PC1 is called Debian. The default name of those virtual machines are Debian. How can I tell this computer I want to tell you that your name is not Debian, but your name is PC1. So there is a command that we saw last time, no? It's called hostname PC1. And since when I started the bash, the name was Debian, it does not update the prompt. So the prompt is still the same prompt as when we started. So what I can do is I exit and re-enter. Look at the name is already there. And re-enter to force it to change the prompt. So now, as you can see, I am the user root on a computer that is called PC1. Okay, so it doesn't have an IP address. We can verify it with ifconfig. So as you can see, it does have an IPv6 address, but it doesn't have an IPv4 address. So I want to tell PC1, your IP address will be, as you can see here, it will be 192.168.0.10/24. So let's use this configuration command, which is ifconfig. So I want to change information of the interface ETH0. And the IP address that I want is 192.168.0.10. And the net mask will be 255.255.255.0. So if I look now, it does have the correct IP address and it does have the correct net mask. So I partially configure PC1. It's not totally configured, it's partially configured. Okay, I booted PC2. So let me double click on it. It is already up and running. Let me enter as root, which is a bad behavior. I should not do that. And I want the configuration of PC2 to be persistent, which means that if I shut down PC2, when it comes back, I want the configuration to be the correct one. So what file should I need? I change. So etc hostname is one of the files that I have to change. In this file, we will have just one line with the name that the computer has to take. So it was Debian, as you see. I'm going to change it to PC2. So Control O to write, Control X to exit. I am out. There is another file that I need to change normally. Is etc host, hoests. And here, it has also information of its old name. I'm going to put PC2 at jsu.edu. And here I'm going to put PC2. Control X, yes. Or Control X, if I didn't save, it will ask me, do you want to save? So I say yes. I didn't do Control O, Control X. I did Control X directly. So it say, oh, you did change, do you want to save? I say yes. And then it exits. Okay, so I did modify the configuration file. However, the PC is still called, here in the prompt, we still see Debian. I can use the command hostname here and put PC2, exit, and re-enter to force the prompt to be updated. So as you can see now, the PC knows it's called PC2. Okay, I want to specify the IP address of PC2. It is there. What is the file that I need to modify? So it's the etc network interfaces file. And in this file, here we have the information of the loopback. And here we have the information of the Ethernet 0 interface. So by default, it gets its configuration through DHCP. I don't want the configuration through DHCP. I want a static configuration. So I'm going to put static. And the IP address will be 192.168.0.20. And the net mask will be 255.255.255.0. Control X. So look, it told me, oh, you didn't write. Do you want to write? Yes, I want to write. It showed me the name. I accept the name and it went out. Okay, so if I look at the configuration up to now, it has not been updated. Okay, it doesn't have an IPv4 address. For it to take into account the IPv4 address, I have to do IF down, ETH0, and then IF up. IF down will disable the interface, and IF up will enable the interface again. And when you enable the interface, it will look at this file. So now we have the correct IP address and net mask. So I should be able to ping, I am in PC2, I should be able to ping PC1. So let's verify it. Ping 192.168.0.10. And as you can see, it does work. So from PC2 in this moment, I'm able to ping PC1, which is good. Okay, let's configure PC3. PC3 is already up. I double click on it here. Let's make a static configuration also, persistent configuration. So I need to edit the file etc hostname. Here I'm going to put PC3. The only information that I need. Control X, I didn't save. So it tells me The buffer was modified. Do you want to save it? Yes. With this name, I just hit enter and I'm out. Another file that I have to modify is the etc host. So I'm going to remove the old name and put PC3. Control X, yes, I want to save with this name, and I'm out. And I'm going to edit. Before I do that, a good practice is to do if down, eth0. I'm going to edit the etc network interfaces file and say that, I use VI this time. Say that I want a static IP address, and the IP address will be, so this is PC3. The IP address of PC3 is 172.18.0.68. And the net mask will be 255. It's a /26. So 255.255.192. I'm going to enable the interface. And I'm going to verify the configuration with ifconfig eth0. So as you can see, we have the correct IP address, which is 172.18.0.68. And look at the net mask is 255.255.255.192, which is a /26. So PC3 is okay. I can reboot PC3, or I see that the name is still Debian here. So I can add hostname PC3, go out, and come back, no? Okay. I'm going to, from PC3, I'm going to try to ping PC1, which is the 192.168.0.10 IP address. What do you think? Is this going to work or not work? So in this moment, I'm in PC3, and I want to ping PC1. What do you think? It's going to work or not work? Okay, it's not going to work. Why? We have not even power on the router. So of course, for a packet to go from PC3 to PC1, it has to go through the router. So first PC3 send it to the router, and then the router send it to PC1. So since the router is not up and running, no way. This ping have to fail. Okay, it did not work. So I'm going to power on the router, and we are going to start configuring the router. So let me start the router. I double click on it. It is booting in this moment. It will take a few seconds to boot. Let me also power on PC5. So when we need PC5, it's already up and running. Okay, the router just boot. I'm inside the router. Let's configure the router for it to be non-persistent, the configuration. So let me just type here hostname, router. Let me go out. On the router now, know that is, oh, I put route instead of router. I will have to do it again. So I go back. I put hostname router. I go out. Now I know that it's called router. I come back. Okay. So look, I'm going to type the command ifconfig. And the router have 3 interfaces, but I only see one interface in this moment. So I can say ifconfig-a for all. Show me the information of all the interfaces. So if you look, this time, it shows me the information of ETH0. It doesn't have an IP address. ETH1 and ETH2. They don't have an IP address. On the loopback, of course. So there is a difference between ETH0 and ETH1. Here in ETH0, it is up. Here it doesn't say it is up. And here in ETH2, it doesn't say it is up. It's why when I type the command ifconfig without -all, It just shows me the interfaces that are up. So in this moment, it doesn't show me interface 1 and interface 2 because they are not up. So I can use the command ifconfig if I want, eth1 up. If you look at now, the interfaces, eth0 do appear in the list. eth1 it appear also because it is up now. Loopback 0 appear, but eth2 does not appear. So I can do the same thing. I want to put eth2 up. So now the three interfaces are going to appear. So the new one is eth2 and it is up. They don't have IP addresses. So I need to put IP addresses in the three interfaces. So look, what will be my IP addresses in eth0? It will be 192.168.0.1/24. Let me put the router a little more in the center. Okay, so let's configure eth0 of the router. So what will be the command that I have to type? Okay, this will be if I want it persistent, but we just want it, we don't want it persistent. So if you reboot the router, it's okay. We are going to lose the information. So what should I type here to configure the IP address in Ethernet 0? So the command will be what? ifconfig Ethernet 0. I want the IP address 192.168.0.1. Net mask 255.255.255.0. Okay? If I look the configuration, all the interface appear, but now Ethernet 0 do have its IPv4 address. It have 192.168.0.1. Ethernet 1 still don't have, and Ethernet 2 still don't have. Which means that PC1 now should be able to ping this interface of the router. Okay, PC1, this guy, should be able to ping this interface of the router. Let's do it. Here I'm in PC1. I'm going to do ping 192.168.0.1, and it should work. Okay, it's work as you can see. Okay? Of course, look what I can do as a practice. It is working, the ping is working. Let me put the ping here so we see it. And look what I'm going to do. For example, I'm going to do the interface 0, put it down. So look at the ping. The ping did stop. And after some time, it's going to tell me destination unreachable or a warning message, no? Let's wait some second to see the warning message. Look at petition 1, 2, 3, 4. It is in 15. It will have it will go much further away because it's trying there. Okay, it takes some time to try. I don't know if we should wait. Let me just put it up. And look at it continue. It was in 15. Now it's continue to 50. So if I do a Control C, it tells me that it tried to send 58 packets. That was packet number 58. It received only 24 answers. So there is 58% of the packet that have been lost, as you can see, no? Okay, so I already put the correct IP address in ETH0. Let's do the same thing with ETH1. How do I put the IP address in ETH1 for the router? So the IP address will be 172.18.0.65, no? Net mask 255.255.255.192. So now the router have an IP address here and an IP address here. It still don't have an IP address in Ethernet 2, no? So we can check it. In Ethernet 2, we don't have the IP address 10.2.5.199, but we do have our correct IP address in Ethernet 1 and Ethernet 0. So can PC4 night ping PC1? Or can PC3 ping PC1? We tried to do it previously. It didn't work. Still don't work. Why? What is happening there? The switch, we don't configure a switch. It's plug and play.
You have to first go to the router and then to PC1?
So it should go first to the router and then to PC1. Now, I have not tell PC3 that there is a router. So PC3 cannot discover that there is a router in the network. So I need a command. I need to type a command in PC3 to tell PC3, oh, there is a router. So look, all the devices have a map. Like when you travel and go to another city, you use a map. There is also a map. The difference that it's not remote city that you want to reach, it's remote network. So for example, when PC3 try to reach PC1, PC3 is trying to reach this remote network. So if you want to see the map of a device, this is called the IP table, the map, what the device knows about the topology. Let's see the map of PC3, which is the routing table of PC3. If I want to see it, I can use the command netstat -n for numerical, R for routing table. This is the routing table of PC3. So look at PC3 know only one network, the local area network, the network where it is. This is the network 172.18.0.64. This is this network /26. It doesn't know about this network or about this network. So when you try from PC3 to reach PC1, PC1 is in a remote network. And PC3 will look at its routing table, which is the map. And in the map, it doesn't see the remote city, which will be the remote network where PC1 is. So there is no way for PC3 to know what to do with the packet, to send it to PC3. So I need to teach PC3 that if you want to reach remote network, you have to send it to the router. So I'm going to use a command to add an entry in the routing table. And this command will be route add net. This network that you see here, I'm going to add it. So I'm going to tell it there is a network, which is the 192.168.00//24. When you want to reach it, PC3, please send it to the router, which is 172.18.0.65. You see why? I am PC3. If I want to reach a remote network, this remote network or this remote network, I have to send it to the router. So I have to send it to this IP address because I am on this LAN. The router have 3 IP addresses, but I have to send it to this IP address, which is 172.18.0.65. Okay, now if I look at the routing table this time has 2 entries. So one entry say, the first entry say the local area network, I can reach it without the help of the router. Why I know it's without the help of the router? There is no gateway. So for example, if PC3 want to reach PC4, it doesn't need the help of the router. Now, look at the second line. The second line say, if you want to reach network 192.168.00//24, you need the help of a gateway. And this gateway have this IP address, which is the IP address of the interface ETH1 of router 1. So now PC3 have a better understanding of the world because you know it's local area network and it's not this network also. But PC3 is still lacking information about this network. So PC3 will not be able to reach this network because I didn't put information in PC3 telling if you want to reach this network, you have to send it to router 1. So it's partially configured, PC3 in this moment. Let's see the case of PC1. Let's see the map that PC1 have knowledge of the world. So netstat -n for numerical -r for routing table. So PC1 in this moment know only the local area network where it is, which is 192.168.0.0/24. We can see it here. And since the default gateway, the gateway is 0.0.0.0, it means that if PC1 wants to reach PC2, it doesn't need the router. It doesn't need help from another device. Okay, on the ping, we did ping between PC1 and PC2, and they were working from the beginning. And the router was not even powered on when it was working. So now let me tell PC1 that there is a remote network where PC3 and PC4 are connected to. So how can I do that? How can you tell PC1, hey PC1, don't think the world is only your LAN. There is a remote LAN, for example, this one also. So how can I teach PC1 that? What can I type? What command? So route, add, net. So the remote network is 172.168.0.64/26. And if I have to send, if PC1 have to send packet to this network, it have to send it to the gateway. What will be the gateway? If PC1 want to reach devices here, it have to send it to who? To router 1. And since router have 3 IP address, which IP address I'm going to choose at the level of PC1 to tell it send it to router 1? Which of the 3? 1. So this one, no, the 192.168.0.1. Okay, so I'm going to say 192.168.0.1. Now, if you look at the routing table, it's no, I am PC1, I know about the local area network, and I know about this remote network. I still don't know about this one. Okay, so now we can try to ping PC3 from PC1. It will still not work, but we can try. So let me do a ping. I am in PC1, and I want to ping PC3. So ping 172.18.0.68. And as you can see, it doesn't work. So why it doesn't work? In this moment, I did tell PC1, if you want to reach this network, you have to send it to the router. So PC1 do send it to the router in this moment. The one that is not doing the job is the router. So let's go to the router and let's see what happened at the level of the router. So let me show you the routing table of the router. On the router, I've knowledge about the 2 network. So for example, the first line say, if I want to reach any device that is in the network 172.18.0.64/26, this is this network, the packet have to go out this interface, which is Ethernet 1, which is correct. And I don't need the help of another router. On the routing table of router 1 also say, if you want to reach any device in this network, which is the 192.168.0.0/24, the packet have to go out this interface, the Ethernet 0. And I don't need the help of any router. I can send it directly to PC1 or to PC2. So the routing table of the router is correct. What happened is that the router is a PC. On a PC by default, don't do routing. So if you want, routing is I receive a packet from one interface and I forward it to another interface. If you want to enable routing in a PC, you have to tell the PC, I want you to do routing, which is receiving a packet on one interface and send it or forward it to another interface. So in this moment, PC1 is sending packet to router 1, and they arrive on this interface. And router 1 should forward them through this interface, but it doesn't do it because it behaves like a PC. So there is a variable in the operating system that you can see with the command system control, sysctl for system control. -A will show you all the variables. So it's a big list. Let me show you. You see, those variables control the operating system. So it's a lot. It's too much. That's true. So there is one that is called net.ipv4.ipforward. I'm going to ask just the value of this one. It is in 0. Of course, if I scroll up, it will be there. Let me search it. There are a lot of variables, as you can see. Net, IP, it is there. You see? It is in 0. When it is in 0, it means that the router should not forward, or the device should not forward. So I want to change this variable in 1. So the device will be able, I authorize the device to receive on one interface and to forward in another interface. So when you want to change it, you use the option -W for write and the value that you want to put inside. I want to put 1, which means I'm telling the router, I allow you to forward. So look at the ping. The ping is not working. As soon as I hit enter here, the ping should be working. So let me hit enter. And as you can see, the ping is starting working because I tell the PC that is here, you can forward. Look at, now I'm going to put it in 0. Look at, the ping is not continuing anymore, as you can see. If I come back and put it in 1 again, so look at, the request is number 264. Look at the next one. It went from 264 to 280. So it loses a lot of, as you can see. But now I already told the router, please behave like a router. Be able to forward. So now PC1 can ping PC3 and PC3 can ping PC1. Okay, let's configure PC5. PC5 is already on. Let's start configure PC5. So I double click on its icon. I enter as root. 2 is the password. Remember, it's a bad habit what I'm doing here. Let's put the name, host name, PC5. Let me exit so I see the name reflected on the prompt of the bash. I come back as root. The password is 2. So I can see now the name is there. The name is reflected. Okay. So it doesn't have any IP address. The IPv4 address in ETH0. So in ETH0 here, they say that we want 10.2.5.130/25. So I'm going to put it. IF config in ETH0 I want 10, 2, 5, 130, and the net mask should be 255, 255, 255, 128, because it's a /25, as they say here. So now if I type the command again, ifconfig, I do have my IP address, my correct IP address. Let me try to ping this IP address of the router, which is 10, 2, 5, 129. By the way, for PC5, this IP address 10, 2, 5, 129 is local or is remote? For PC5, it's local. Okay, all this interface and these two PC belong to the same network. Now for PC5, this IP address 192.168.0.1 is local or is remote? It's remote. Okay, so let's try to ping. Do you think that is going to work or not? What do you think? It's not going to work. Why is not going to work? Because we didn't configure ETH2 in the router. So the router doesn't have this IP address. So if I try, look, okay, I cannot reach it. So let's go back to the router. Let's see its configuration. And as you can see in Ethernet 2, we don't have IPv4 address. So I need to tell that this IP address in Ethernet 2 is going to be 10.2.5.129/25. So let's do it. I am in the router, ifconfig, ETH2, the IP address will be 10.2.5.129. And the net mask is going to be 255, 255, 255, 128. Okay, let me do that. Now, if we type the command ifconfig, I do have my IP address. So now if we try, again, it will work. 10, 2, 5, 120. Oh, it's 130. You see? And I put 120. Let me modify that. It's 130. Okay, so the ping work. Okay. Now, can PC5 ping PC1? What do you think? No, why not? We never told PC5 that there is a remote network where we have PC1 and PC2. We never told PC5 that there is a remote network where we have PC3 and PC4. So PC5 at this point only know the local area network. If PC5 need to communicate with a remote network, you have to tell PC5 that this remote network exists. So let's put a command in PC5 to teach PC5 that there is a remote network where PC1 and PC2 are. So what command should I type here? The command route, no? Yeah, route add net, you're right. So before I do that, let's verify the routing table of PC5. So remember, what is the routing table? It's like the map, what PC5 know. This will be for us the map. So let's see. PC5 know only one network, the network where it is part of. It is part of the 10.2.5.128 network /25. It doesn't know this remote network. So there is no way for PC5 to send a packet to this remote network, because we need to tell PC5, if you want to reach this remote network, you need to send the packet to R1, to the router. So let's add a command with route add a remote network in this case. That will be 192.168.0.0/24. It is there, no? If you want to reach this remote network, you need to send it to who? So GW is for gateway. Gateway is who is going to help me? Who is the next hop? When a packet go to a destination, can make several hop. Who is the next hop? I have to send it to whom? I have to send it to the router. So the router have 3 IP address. So PC5, if you want to reach this router, will use which of the 3 IP addresses? Which one of the 3? Will it use 192.168.0.1, 172.18.0.65, or 10.2.5.129? Which one of the 3 one? Yeah, I always use the IP address that belong to the same network where I am. So I am PC5. Of these 3 IP addresses, only one is local. I have to use the local one. So the local one is 10.2.5.129. So now, what do you think? If I try to ping PC1, will it work? If I try to ping, I'm in PC5. I'm trying to ping, for example, 192. Okay, if I ping my default router, of course it's work. We already saw that. Let me try to ping PC1. So what do you think? It will work or it will not work? So it will not work. Why? So PC5 already know that this remote exists, this remote network exists. And PC5 know that if you want to reach this remote network, you have to send it to the router. The router send it to PC1. What is happening? That PC1 don't know about this remote network. So the packet will go from PC3 to the router, from the router to the PC1. But ping, the packet go and come back. The problem is that it can go, but it cannot come back. Why? PC1, the routing table of PC1 don't know what to do to reach this network. So look at the ping, it's not going to work. You see, it doesn't work. So I go to PC1. There is a way for me to show that PC1 is receiving the packet that come. So let me see if we have a tool that is called TCP dump. We have it. So TCP dump, I'm going to tell it to capture on this network. -I. Look at, I am receiving the echo request, but I'm not sending echo reply. Look at the echo request. They came from 10.2.5.130. 10.2.5.130 is PC5, and they came to me. I am 192.168.0.10. But I don't send the reply. Why I don't send the reply? Because I look at my map, there is no information. What should I do to reach PC5? Because the packet go from PC5 to PC1 and back from PC1 to PC5 with ping. From PC5 to PC1 and back from PC1 to PC5. So let's look at the routing table of PC1. Let's start -NR, N numerical R routing table. Let me put it. Look at PC1 know about the local area network, which is this entry, the second one. PC1 also know about this network, which is the network where PC3 and PC4 are, which is 172.18.0.64. It is there in its map. But in its map, there is no information about how to reach PC5 and PC6. So let's add that in PC1. What should I type? What is the command? Route, add, net. What should I put there after? You are telling PC1. If you want to reach this network, what is the network? The network 10.2.5.128/25. What should you do? You should send it to the next hop. Who is the next hop? What should PC1 do with a packet that go to PC5? It should send it to the router. So here I need to put an IP address that corresponds to the router. The router has 3 IP addresses. Which one I'm going to take? Remember, we take always the local one. What is the local one if I'm PC1? Correct, 192.168.0.1. As soon as I hit enter, you see this ping that doesn't work will work. So let me hit enter. Look at the ping. Why? Now, because PC1 knows what to do. Because I just told PC1, if you want to reach this network, you have to do that. Now look at the command that we typed previously, the TCP dump. It will show echo request, echo reply, echo request, echo reply. Look at it. You see, echo request, echo reply, echo request, echo reply. Let me stop it. Look at the echo request. Who is doing the ping? The ping, we started it in PC5. So the echo request go from PC5 to PC1. On PC1, reply with an echo reply that go from PC1 to PC5. So if I look at the echo request that go from PC5 to PC1, what will be the source IP address? The echo request go from PC5 to PC1. Who is the source? PC5, correct. So the source IP address will be the IP address of PC5, which is 10.2.5.130. So look at here. It's go from 10.2.5.130. Who is the destination? The destination is PC1, which is 192.168.0.10. So look at the destination is 192.168.0.10. This is the echo request. So PC1 have to send an echo reply. So in the echo reply, who is going to be the source? PC1, which is 192.168.0.10. So if you look the source, 192.168.0.10. Who is going to be the destination? PC5, which is 10.2.5.130. You see? So if PC1 don't have all the information, now PC1 know the tree network. So PC1 have all the information. So PC1 can communicate with any device. If I look at the level of PC5, let me go back to PC5. Look at the routing table of PC5. What can you tell me with this routing table? Can PC5 reach, for example, PC2? Why not? He doesn't know PC2, but he knows the network of PC2. Look at this entry. This entry say, for any device that is in this network, look at this entry. It say, for any device that is in the network 192.168.0.0/24, PC5 have to send the packet out this interface. It's the only interface that it has. So it will send it out this interface and send it to somebody that is going to help it. And this somebody is the router. And the IP address of the router is this guy, which is 10.2.5.129, which is the IP address that we have on Ethernet 2. So yes, PC5 will be able to reach PC2. So let's do a ping The problem is that PC2, we didn't configure PC2 to send the echo back. So the echo will go, but it will not come back. So let me do ping 192.168.0.20. So PC5 is well configured already. It doesn't work. But if it does not work, it's not the fault of PC5. The problem is PC2. So let's go to PC2. And let's see the map, what PC2 know. So let's do net stat -nr. Look at what PC2 know. What can you tell me about PC2? You know about which network? Only the local network, which is the 192.168.0.041/24. It doesn't know about this network where are PC3 and PC4, and it doesn't know about this network where are PC5 and PC6. So of course, all the devices on the path are correctly configured already, but PC2 is not. If you look, let me run TCP dump here to show you that the echo requests do arrive. So size 0, interface ETH0. So I will see the echo request. Look at the echo request. They do arrive. You see? Echo request, they do arrive. What is happening? That the configuration of PC2 is not complete. So PC2 is not able to reply. So it's why the ping from PC5 does not work for now. So what should I do in PC2? Yeah, root add -n what? So I am PC2. And I want to tell PC2, oh, there is a network here, a remote network. So first I have to give the name of the network. What is the name of the network? Or what is the address of the network? I need to say, add to your routing table this remote network. What is the remote network that I want to add? Exactly, 10.2.5.128 /25. And I'm telling PC2, if you want to reach it, you need the help of a gateway. Remember, GW is gateway. On this gateway, what will be this IP address of the gateway? So remember, the router has 3 IP addresses. If PC2 want to reach the router, PC2 have to send it to this IP address that is on Ethernet 0, because this is the local IP address. So I will put here 192.168.0.1. Look, as soon as I hit enter, look at the ping. It's not working. Let me hit enter. You see the ping now? It's working. Because now PC2 know what to do to reach PC5. It was not the case at the beginning. Okay. Can PC2 reach PC5? Yeah. If PC5 can reach PC2, PC2 can also reach PC5. Can PC2 reach PC3? No, correct. Why? Because we didn't tell PC2 that there is a remote network where PC3 and PC4 are. So let's do it. So look at the map. The map is the routing table. PC2, no, its own network. Its own network is this one, the local area network where I am. PC2, no, a remote network where we have PC5 and PC6. But PC2 don't know the remote network where we have PC3 and PC4. So I'm going to tell PC2, let's try to ping first, and it will not work. So ping 172.18 068 will not work. You see, destination unreachable. So I'm going to put route add net. What is the network that I need to teach to PC2? Correct. Correct. 172.18.0.64/26. What should I put after that? The gateway. So GW for gateway. And who is going to be the gateway? Correct. 192.168.0.1. So now, look, the ping that was not working previously now work. Why? Because now, if you look at the routing table of PC2, let's see the routing table of PC2. It knows about all the three networks that are in this internetwork. So it will know what to do. You see? So let me configure what we have. Let me start PC4. It is already started. Let me configure PC4. And we are going to show an easier way to configure PC4 than we did for the previous devices. So let me enter as root. The password is tour. Let me change the host name. And let me put PC4. Let me exit. The host name is updated in the prompt. OK. So I don't have IP address in my ETH0 interface. I am PC4. My IP address is going to be 172.18.0.72. So I'm going to put ifconfig. The interface is ETH0. The IP address is 172.18.0.72. And the net mask is /26, which is 255.255.255.192. So now PC4 have an IP address. So look what we are going to do. From PC1, we are going to ping PC4. Will it work or it will not work? So PC4 is 172.18.0.72. Will it work or will it not work? It will not work. Why? PC4 only knows its local area network. So remember, you are in PC1 and you ping PC4. PC1 is already well configured. So the echo request will arrive to PC4. What will happen? PC4 don't know how to reach PC1. So PC4 cannot send the echo reply. So it will not work. Look, it doesn't work. Even if PC1 is well configured. So PC5 is also well configured. If I go to PC5 and I try to ping PC4, let me just copy this command and paste it here. It's not going to work neither. Why? I'm PC5. PC5 is not totally configured. It looks like, no? OK, PC5 don't have information about this remote network up to now. So let's add it. So route add net 172.18.0.64/26. You need to use the gateway, which is 10.2.5.129. OK, so now if you look, PC5 is totally configured. Let me do the ping, and it doesn't work. The same reason, PC4 don't know this remote network, so you don't know how to answer to PC1. And PC4 don't know this remote network, so you don't know how to respond to PC5. But if you run TCP dump -s0 ETH0. What do you think that we are going to see? An echo request that's come from PC1 and an echo request that comes from PC5. But PC4 will not respond any of them. So we see two different echo requests. Let me do it. Okay, you see it? Let me stop it with a Control-C so we can study it. Look at the first one. The first one goes from where to where? So it's go from 10 to 5130. Who is this device? PC5. This is PC5, send it to PC4. And PC4 don't know how to reach the network of PC5, he cannot answer. Look at the second one that we have. The source is 192.168.0.10. Who is this device? PC1. So we can see that both PC5 and PC1 are sending echo requests to PC4. But PC4 does not answer. Because let's see the map or the routing table of PC4. PC4 only know the network where it is. So we need to add 2 entries in the routing table of PC4 so it knows the 2 remote network. So instead of adding 2 entries, there is a way to add only 1 entry. And I'm going to show you this way. And it will, because look at PC4. If PC4 want to reach the network of PC1 and PC2, or the network on PC5 and PC6, what does PC4 have to do? In both cases, it have to send it to router 1. So instead of putting 2 lines saying, in the first case, you send it to PC1, you send it to router 1. In the second case, you also send it to router 1. I can put just 1 instruction and say, in all the other cases, send it to PC1. So I'm going to do that. So look, how do I do that? Route add net 0000/0 gateway 172.18.0.65, which is in all the other cases, I'm telling PC5, send it to router 1, send it to the router, which is 172.18.0.65. So look at, this is called the default route, which means that if you want to reach any device that is not in the local area network, send it, which means it's in a remote network. I'm telling PC4, send it to the router. Okay? So when I hit this, what will happen? Both ping are going to answer. Why? Because with just one command, I'm telling PC4, for all the other network, all the remote network, send it to router 1. So now our PC4 know that any remote network, it have to send it to router 1, to router. So as soon as I hit this ping and this ping will start working. So let me do it. I hit it, look at both of them starting working. Why? Because PC4 now know that in all the other cases, if it's not for the local area network, for example, if it's not for PC03, for any other remote network, you have to send it to the router. So this is much easier to use the default route than to put a lot of entries in the routing table if there is only one way to exit. Let's say that we don't have this door here. And you tell me, I ask you, I want to go to Miami. What should I do? So you will say, exit this door, because this is the only door. Then I say, I want to go to Philadelphia. You will say, exit this door, because this is the only door. Everywhere I want to go, you will say, exit this door. Now, if we have two doors, and I say, I want to go to the cafeteria, you will say, exit this door. But if I say, I want to go to the international house, you will say, exit this door. Because the international house is this way, and the cafeteria is this way. So of course, if you have several exits to go to a remote place, you better take the best one. So in the case of PC4, what I'm saying that any remote places you want to reach, you need to send it to the router. This is what I just tell PC4. It's better to say in the end devices, like all these PC, it's better to use a default route than to tell them if there are 20 remote network, you are not going to type 20 line. You just have one line that say, all the other remote network, there is only one exit here, so take this exit. So the router have a better vision because the router have several interfaces, but the PC have just one interface, one way to go out. So if it's not for the local area network, I do have to send it to the router that will take care of forwarding. And doing hop like that, the packet will reach its destination. Did you understand? So, in conclusion, for this exercise, when I configure PC1, I type to add net command. I could just have type 1 because PC1 have only one way to go out of the local area network, and it's through router 1. So I could have just said PC1. In all the other cases, if it's not for the local area network, send it to the router. I could have done the same thing for PC2, for PC3, for PC4, for PC5, and for PC6. Do you understand that? So let's see if I want to do this configuration persistent, what should I do? Look at. Here I'm at the level of the router. I put 3 IP addresses. Let me show you this file. This file, if I want to do it persistent, I should put here static address. What is the address that I should put here? I am configuring this interface. So what will be the address? Correct, 192.168.0.1. What will be the net mask of this interface? Correct, 255.255.255.0. Now, I'm going to copy this 4 line. And I'm going to say, okay, there is another interface, which is ETH1. So for ETH1, the IP address is 172.18.0.65. And the net mask is this one. Okay, and I'm going to say there is another interface, which is ETH2. And for ETH2, the IP address is 10.2.5.129. And the net mask is a /25. So it will be like that. So you see, in the /etc network interfaces, we put the information of all the interfaces. Of course, if I want the name to be persistent, I have to modify this file. It's not Debian. Let's call it O router OR01. And there is another file that I have to modify. And here I have to put router on router. So there is one more file to modify. You remember that we did the command syscontrol write in the variable net.ipv4.ipforward put 1. We did that with a command that is not persistent. If I want this command to be persistent, there is a file that I need to change. So the file is called etc syscontrol.conf. And in this file, we have a lot of variables. So look at my variable. Here there is a comment. Uncomment the next line to enable packet forwarding in IPv4. It say put it in 1. So I'm going to uncomment it. I'm going to save and quit. Now if I reboot the router, let's do it. Everything will be okay. So let's do a ping. Look at this ping. It does work and this ping does work. When I boot the router, it will go down. For a few seconds, the two ping are going to stop. And when the router comes back, the ping are going to continue. So let me do it. Look at the ping. Here, it stopped in 785. And here in 729. So the router is booting. 789, 789, that, you see? Went back, the ping are working again. So look at the router. It's not that its name is router. Let me enter as root. And let me type ifconfig. So now, it knows its IP address on ETH0. And its net mask, of course. It knows its IP address in ETH1 and its net mask. And it's know its IP address in ETH2 and its net mask, because I put them in the file. Now, if I ask, show me the variable net IPv4 IP forward, this variable will be in 1. Why? Because I did modify the file. And this one means you are a router, so forward. You receive on one interface, I am telling you, you should send it to another interface. Remember, if this variable, I put it in 0, look at the ping, they are working both, no? As soon as I do that, look at the ping. Doesn't progress anymore, 874, and here 810. Until I come back and put them in 1. So let me put it here. So look at the ping, 810, 874. They don't continue. And they started to continue, 896, and here 834, 35, because I'm telling the router, please forward. Forward is receiving on one interface, sending to another interface, according to the routing table. The routing table is what guides the router what to do with packets. The routing table also guides the PCs. So if I want to configure PC5 and I want its configuration to be persistent, look at what I can do. Let me see the host name. I don't remember if we change it. No, it's still Debian. Let me put PC5 here. The other file, etc host. You are not Debian, you are PC5. This is the short name. You are PC5. So, for example, I can do ping PC5. I can do ping PC5jsu.edu. So one is the full qualified domain name, and the other is just a short name. Okay? People prefer name over IP addresses. We memorize name. We don't memorize IP addresses. But everything works with IP addresses. So the other file that I need to change is this file. So look at what I'm going to do. Static. What should I put after that? I'm configuring PC5. Help me there. Here is the information of PC5. So what should I put? Yeah, address. So 10, 2, 5, 130. Then what? Net mask 255, 255, 255, 128. Okay. We did type a command, an additional command in PC5 or several. The command was route add net. The easier ways will be with the default route 0000/0 gateway 10 2 5 129. Okay, we type that. You remember? So it's know that if PC5 want to reach remote network, it have to send it to the router. If I don't put this line in the file, it will not be well configured because it will only know the local area network. To put this line on the file, you need to put first up. This up is when the interface is up, type this command automatically. So it's when the interface is up. So that will be a correct configuration of PC5. Which means that any device that will ping to PC5, if you reboot PC5, it will come correctly. So let's say here I'm PC1, I'm going to ping PC5. So PC5 is 10, 2, 5, 130. And of course it's work. So I'm in PC1. I'm going to go in PC4 and do the same thing. So let me just copy the command here. Okay. Ping 10, 2, 5, 130, it's work. Look, I'm going to reboot PC5. What is going to happen if I reboot it? Can reboot it with init 6, with reboot, with shutdown, -R for reboot now. So the two ping are working. If I reboot it, they will stop working for some time. And as soon as PC5 come back, the ping is going to continue. Okay? Why? Because the configuration of PC5 is now persistent, because I put it in files. It's not only on RAM. Okay, let me boot PC5. So PC5 go down. Look at the ping here, 64. It has stopped, and here 49. PC5 is already did shutdown. Is going up now. So look at the request went from 64 here to 75, as you can see, no? And here it went from 60, where it was in 49 to 61. You see, that was the time that PC5 boot. Look at PC5, know its name. Let's see the routing table of PC5. How many entries do you think the routing table of PC5 will have? How many lines? 2. One that say, if you want to reach any device in the local area network, you go at this interface, which is ETH0, and you send it directly to the device. You don't need the help of the router. And the second entry will say, if you want to reach any remote network, you go at this interface and you send it to the router. So we should have 2 entries. Let's verify. We have 2 entries. So let's see what this entry say. Look at the first entry. The first entry say, if you want to reach a device that is in this network, which is the 10.2.5.128/25. So 10.2.5.128/25, you go at this interface and you don't need the help of the router. You can reach PC5, can reach PC6 without the help of the router. Now, look at the second entry. It's a 0.0.0.0/0. So a /0 in the dotted decimal notation is 0.0.0.0, the mask. So any other remote network, go out this interface. I just have one. So when I go out, I have to go through this interface. But this time, you need the help of the router. You see what it's saying? So it's why PC5 is completely configured. Another way to configure PC5 will be to put 2 lines here. I can do it. So if I do 2 lines, I will say, okay, if you want to reach this network, which is the 190.168.0.0/24, send it to the default gateway. And if you want to reach the network where PC3 and PC4 are, which is the 170.80.0.64/26, so I can put these 2. But why put 2 if I can put just 1? Okay, this is what I want to tell you. So here, putting these 2, it will also work. On PC5, is perfectly configured. But instead of putting 2, we are going just to put 1, which is the default case. All the other remote network send it to the router, and this is just perfect. Okay? Remember, you have homework number 1. I think you have up to another 2 days or 3 days. Be sure you submit this homework. Okay? Okay, have a nice weekend. I see you.